There is a ring in the sky so enormous that according to our best theory of the universe, it simply should not exist. It's a ring of galaxies, 1.3 billion light years across, and if you could somehow see it from Earth, it would span as much sky as 15 full moons laid side by side. But its size isn't the real problem. The real problem is that a structure this big breaks one of the deepest assumptions in all of cosmology. And it isn't even the only one out there. It's called the Big Ring, and it was discovered in 2024 by Alexia Lopez, an astronomer at the University of Central Lancashire. It sits an astonishing 9.2 billion light years away. So far that the light we're seeing left it when the universe was about half its current age. It's built from galaxies and galaxy clusters, strung out in a vast, almost perfect circle, with a circumference of roughly 4 billion light years. Sit with that number for a second. If you set off around this ring traveling at the speed of light, which is fast enough to lap the Earth 7 times in a single second, it would still take you 4 billion years to get back to where you started. It's one of the single largest things ever found in the universe. To understand why astronomers are unsettled by it, you need one rule. It's called the Cosmological Principle, and has been the second most fundamental assumption in all of physics, right behind Einstein's relativity. The idea is simple. On the largest scales, the universe should be smooth and even. Look in any direction, travel to any region, and the matter should be spread out about the same. You can have galaxies, clusters, even huge walls of galaxies, but only up to a point. Beyond a certain size, everything is supposed to average out in a featureless, uniform haze. And that limit can be calculated. According to the standard model of cosmology, there simply hasn't been enough time since the Big Bang for gravity to assemble any bound structure larger than about 1.2 billion light years. The Big Ring is bigger than that. By the rulebook, it never should have had time to form at all. If it were a lone oddity, you could maybe shrug it off as a fluke, but well, it isn't alone. In the very same patch of sky, at the very same distance, sits another monster. Lopez had already found it 2 years earlier, the giant arc, a sweeping arc of galaxies 3.3 billion light years long. The Big Ring and the giant arc are separated by just 12 degrees on the sky, and they sit at the same distance, which means they existed at the same moment in cosmic history. Two impossible structures, side by side, in the same corner of the early universe. Lopez and her colleagues suspect they might even be parts of one single, even larger system. And they're not the only giants. There's the Sloan Great Wall, there's the Hercules Corona Borealis Great Wall, which stretches an almost incomprehensible 10 billion light years, the largest structure ever found. One by one, these discoveries keep piling up, and every one of them is too big for the rulebook. The Big Ring isn't a single exception. It's part of a pattern that's getting harder and harder to ignore. So how do we even find the ring of galaxies 9 billion light years away? The method is almost as strange as the structure itself. You can't simply photograph something this faint and this far away. So instead, Lopez used the light of quasars, blazing beacons powered by supermassive black holes in the distant universe. As a quasar's light crosses billions of light years to reach us, it passes through everything in its path. And when it passes through clouds of gas around galaxies, certain atoms, in this case magnesium, absorb part of that light, leaving a chemical fingerprint stamped into it. By reading those fingerprints across the sky, astronomers can map where the matter is, even when the galaxies themselves are too dim to see. The Big Ring emerged from that map, traced out in magnesium, hidden in the data from the Sloan Digital Sky Survey. And there's a final twist in the shape itself. From our point of view, it looks like a near-perfect ring, turned almost exactly face-on towards us. But when Lopez examined it more closely, it wasn't a flat ring at all. It's closer to a coil, a corkscrew, that just happens to be orientated so that from Earth we read it as a circle. Nothing in our models predict a shape like that on anything close to this scale. So what could possibly make a ring of galaxies 4 billion light years around? The honest answer is that nobody is sure, and the candidates get stranger the further you go. One idea is something called baryon acoustic oscillations, frozen ripples left by sound waves that echo through the hot plasma of the infant universe, which can leave a faint, shell-like rings of galaxies behind. It's a real and well-understood effect, but the shells it produces are the wrong size and the wrong shape to account for the big ring. It just doesn't fit. A stranger possibility is cosmic strings, hypothetical flaws in the fabric of space-time, thinner than an atom yet stretching across the universe, left behind from its first fractions of a second. If they exist, they could in principle herd matter into vast loops and arcs. We've never confirmed a single one, but the Big Ring is exactly the kind of structure that might point to them. And at the far edge of speculation, a few have asked whether rings like this could be imprints from before the Big Bang itself, faint echoes of a previous universe, and the cyclic cosmology picture proposed by physicist Roger Penrose. There's no consensus on any of it. Every explanation either doesn't fit the data or relies on something we've never proven exists. And this is why it carries so much weight. The cosmological principle isn't a footnote. Almost the entire edifice of modern cosmology is built on top of it. As one physicist put it, without the assumption that the universe is smooth on the largest scales, all hell would break loose. If structures like the Big Ring are real and genuinely can't be explained, then the standard model of the universe may be incomplete, and it would ripple outward. The smoothness assumption is quietly baked into how we measure the universe's expansion, its age, even the behavior of dark energy. So a real crack in it wouldn't stay contained. It would reach into almost everything we think we know about the cosmos. And it isn't only outsiders saying so. Jim Peebles, who won the Nobel Prize for helping build that very standard model, has said these ultra-large structures might well be real and significant, and that the model itself is very likely only an approximation. He said that he's hoping for exactly these kinds of anomalies, because they could be hints that point toward a better theory. Lopez is careful too. She isn't claiming the model is wrong. The honest position is that we don't yet know whether the Big Ring is a true crack in our understanding or a rare arrangement we simply don't grasp. What comes next is more data, new surveys mapping millions more galaxies, to find out whether these giants are everywhere, or whether we just happen to stumble onto the exceptions. For now, the Big Ring just hangs there in the data. A circle of galaxies 4 billion light years around, 9 billion light years away, sitting in a region of sky where by our own rules, it has no right to be. Maybe it's a fluke. Maybe it's some echo of the early universe we don't yet understand. Or maybe it's the first clear sign that the cosmos is stranger and less orderly than the neat model we built to describe it. That's the part worth holding on to. The people who built the standard model are the ones most eager to see it challenged. This channel is about exactly these moments, when a single observation forces us to ask whether we've understood the universe at all. If that's your kind of thing, subscribe. And if this one was worth your time, a like genuinely helps the channel grow. Thanks for watching. Clear skies.